Hi, welcome to the Olympiad geometry. Let's continue our study. Here I start a new series of video called A Problem a Day, which I post the problem on day 1 and the audience can try to solve the problem. Then I post the solution video on day 2. So the problem will be posted on the community and the solution will be posted as a video in the second day. Okay, let's see our first problem. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. In equilateral triangle ABC, extend BC to D, extend BA to E. Let AE equals to BD. Connect CE, DE. Prove that CE equals to DE. This is a problem from Beijing mathematics computation in 1982. So let me explain this a little bit. The problem I choose based on a problem collection book, which actually already categorizes the problems in several different ways, right? So for here, it's like all the problems are about the relation of point or segment. Okay, so let's just see this problem. First, we find a equilateral triangle here. And we extend BC to D. And also extend BA to E. And we let AE equals to BD. So BD is about this much. So AE about this much. Okay. This is E. AE equals to BD. And connect CE and DE. Now we want to prove that CE equals to DE. So for this problem, I have 2 ways to solve it. Let's talk about it one by one. For solution 1, the first thing that we notice here, we want to prove that CE equals to DE. And we also notice that triangle ABC is an equilateral triangle, which means this is 60 degrees. So that just makes us to think of drawing a perpendicular line from E to BD. And let's set this as F. Okay, so this as F. And because we already know that triangle EBF is a right triangle, right? And this angle is 60 degrees. That means twice of BF equals to BE. Right, twice of BF equals to BE, which equals to BA plus AE. Right, which equals to BC plus BD, right? BC plus BD, which means BF minus BC equals to BD minus BF. That means BF minus BC, that is CF, equals to BD minus BF, that is FD. Okay, because CF equals to FD and EF is perpendicular to CD, so we know that EC equals to ED, right? CE equals to DE. I think that's a very straightforward thinking, because we have this 60-degree here, and we want to prove that CE equals to DE. And by doing a perpendicular line here, we have a very specific triangle which has a BF equals to half of BE, right? And that helps a lot. So we do this auxiliary line. And we can have another solution, which is to just extend BC to another point G, right? So form BEG to be an equilateral triangle. So make BEG to be an equilateral triangle, right? So we know this is another equilateral triangle, and we already know that CG, because this is another equilateral triangle, so we know that CG equals to AE, right? So we know that CG equals to AE, which equals to BD, right? So CG equals to BD. And also we know that EG equals to EB, right? Because triangle EBG is an equilateral triangle. So EG equals to EB equals to EG, right? And this one equals to this one. And also angle EBG equals to angle EGB equals to 60 degree. So we know that triangle ECG is congruent to triangle EDB, which means EC equals to ED. Okay, so both solutions are not very difficult to figure out. I think this is a problem on the maybe 8th grade or 9th grade level. Okay, I hope you liked this video. See you in next one. Thank you.